All right, this is section 5.1. This is the continuation of what we did before. This is adding and subtracting polynomials. So we're going to talk about that. So what is a polynomial? A polynomial is a collection of letters and numbers. So as you can see, you've got letters, you've got numbers, letters, numbers, letters, numbers. So it's a very generic thing. It's a very general term. It's sort of like the word number. What's a number? Well, 2 is a number, 3 is a number, 4 is a number. What's a variable? X, Y, Z, A, B, C. It's a very generic term. Polynomial is kind of a generic term that we also use. So typically, it's just a collection of letters and numbers. There are things that are not polynomials. They have fractions in them, for example. But for the most part, most of the time when you see letters and numbers put together in some kind of way, it's probably a polynomial. Now, these can be divided into parts that are called terms, which we talked about before. There's a prior video to this. It's called section 5.1. You can go look at that one, which talks about terms in greater detail. A term is one part of a polynomial. It has 3 parts. So a polynomial can be split into parts called terms, right? So this is a term, and that's a term. But then a term can be split into parts as well. So you have the coefficient, which is the front number, the number out in front, a variable, which is a letter, and an exponent, which is a power. That's what this thing, we call this an exponent. Two terms are called like terms if they have the same variable and the same exponent. So we see here you have 2x, 19x, 4w, 10w, 32a to the squared, or a to the 2, 9a to the 2. So usually, if you want to figure out what the like terms are, you don't have to overthink it. They're the ones that look the same. So like this one, 32a squared and 9a cubed look different because one has a 2 at the top, the other one has a 3 at the top. They're not the same. If you have 12r and 12s, that's pretty obvious they're not like terms. You have different letters. And this one's a little more tricky. You've got 4w and 10w squared. But if you notice, this w is by itself. This w has a 2 attached to it. So we can tell that this and that are different. All right. Now, if you want to add or subtract 2 more terms, they have to be like terms. So I can add these together, subtract those, add those, and add those. I cannot do that for this right here. Let me make a quick note. We can multiply or divide unlike terms. So a squared and a cubed can be multiplied together, but not added together or subtracted. So I can multiply it, I can divide it, I can't add it, I can't subtract it. If they're not like terms, you cannot add or subtract them, but you can multiply or divide them. So we'll get to that later. All right, unlike terms. So 2 terms are called unlike terms if they have either different variables or different exponents, i.e. powers. Again, you can add or subtract them if they're like terms. If they're not like terms, you can't add or subtract them. Again, that's the basic criteria for being able to combine like terms. If you want to add or subtract 2 terms, they have to have the same variable raised to the same power. All right. So this is a summary of that. I'm hammering home this point because in mathematics, typically what happens is you have a really long problem and you do all of these steps. And the big $1 million question is, when do I stop? I mean, that's the $1 million question. You're trying to figure out, when do you stop? When can I no longer put things together? When can I no longer multiply or divide or whatever? This rule, combining like terms, sort of gives us some structure and says, you can no longer add these together. You can't push these terms together anymore. This is it. This is as far as you can push these terms. All right. So for example, you can add 4x and 5x. So if I have 4x and 5x, I can make that into 9x. If I have 4x and 5y, I can't put that together. They are just separate things. They're completely separate and will be separate. I can't add 4x and 5y. I have 4x and 5x squared. I can't add those either because one is an x and one is an x squared. But let's say that I have two things I can't add together. How do I do it? So the way I combine terms is I add or subtract the coefficients. I keep the variable the same. So notice I have a 4 plus 3 gives me a 7, x, 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 not x squared. X, x, x. So we'll look at two examples of like terms and two examples of like terms, two examples of unlike terms, and we'll basically see what happens when we have like terms we're adding or subtracting and unlike terms we're adding or subtracting. So let's take the first one. I want to add 3x plus 7x. I add 3 plus 7 gives me 10. X, x, keep the x, so we get 10x. Y, x, x, x. So 3 plus 7 is 10. X, 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 we get 10x. So if you notice, x, x, x. So 3 plus 7 is 10, x, x, x. The x stays the same. We don't change the x. All right. Now we're going to subtract 6x squared minus 5x squared. So first thing we do, we subtract 6 and 5. 6 minus 5 is 1. We keep the x, and this should be x squared. I apologize for that typo. I'll get that corrected when I send out the actual PowerPoint. But this should be x raised to the 2 power, not next to the 2 power. All right, so we get 1x squared. So 6 minus 5 is 1. We have x to the 2, x to the 2. So our final answer is going to have x to the 2. Notice that we have x to the 2, x to the 2, x to the 2. We didn't subtract the 2's. We didn't change anything. It's not 4, it's not 0. It's 2, 2. It stays a 2 for exponent. The only thing that changed was we said 6 minus 5 equals 1. So 1, 6 minus 5, x to the 2. All right. Those are like terms. These are unlike terms. 9x and 7x squared are unlike terms. They have different exponents. We can't add them. All you can do is say 9x plus 7x squared equals, what was it equal to? Well, we can't say 16, x to the 3, no, we can't do any of that. We cannot do anything with it. The only thing that we can do with 9x plus 7x squared is say 9x plus 7x squared. We can't add the coefficients. We can't add the exponents. We can't do anything else with it. Because they are unlike terms, they can't be added. And because they can't be added, we just go, okay, 9x plus 7x squared, what can I do with it? Nothing. 9x plus 7x squared is it. That's all we can do with 9x plus 7x squared. All right, second example, I have 8x minus 7y. Those are clearly unlike terms. One's an x and one is a y. I can't subtract them because one's an x and one's a y. They're unlike terms. So what can I do with 8x minus 7y? Well, all I can do is say 8x minus 7y. I literally cannot do anything else to it. I can't add those together. I can't subtract those from each other. All I can do is say 8x minus 7y is 8x minus 7y. That's it. All right. Again, I'm trying to hammer this point home because we need to get to the point where we go, this is how, when do we stop, essentially? All right, let me do another example. These are some that I worked out on paper, and I'm putting on this thing here. Excuse me. I have 7y plus 5y minus 9y. So 7 plus 5 is 12. 12 minus 9 equals 3, so 3. And then what is it? Well, it's y, 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 y. 3, y. We're adding and subtracting terms. So I add those, subtracted that one. And I got a new coefficient, which is 3. And I have y, 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 y. The y stays the same. Okay. 3y. That's the final answer. That's it. That's all we can do. All right. If I have 2w cubed plus 4w to the 3 minus 5w to the 3, I take 2 plus 4 is 6. 6 minus 5 gives me 1. And so now I have 2w to the 3 plus 4w to the 3 minus 5w to the 3. Well, 2 plus 4 minus 5 is 1. And this is w to the 3, so w to the 3, w to the 3, w to the 3 gives me w to the 3. The simplest way I know to explain this concept is to think of it like apples and oranges. This is apples. You have 2 apples plus 4 apples minus 5 apples is how many apples? Well, if you count all your apples up and subtract them, you get 1 apple. So that W3 is like an apple. Here I have 7 oranges plus 5 oranges minus 9 oranges is how many oranges? Well, it's 3 oranges. So we have to keep everything the same. If I have 7 oranges plus 5 oranges minus 9 oranges, I don't get 3 apples. It stays oranges. If I have 2 apples plus 4 apples minus 5 apples, I don't get 1 banana. It stays apples. So W3, 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 if I'm just adding stuff together, simple, it just stays the same. So 2W3 plus 4W3 minus 5W3 give me 1W3. All right. One more. I have y to the 3 plus 3y to the 3 plus 4y to the 3. Now, before I do anything else, I have to remember that in math, we do this thing called the invisible one. So here, even though I don't see a coefficient, I might say, well, there's no coefficient. Yes, there is. The coefficient is our invisible one. So I would, before I do anything else, take an extra step and write my 1 out. So now I have not just 0 plus 3 plus 4, I've got 1 plus 3 plus 4. I put in my calculator, I get 8. 8 what? Well, I've got y to the 3, y to the 3, y to the 3, stays y to the 3. Okay, 8y to the 3. Now let's say that we have things that are mixed up. So we have not just so before we had 7y, 5y, and 9y. Everything has a y on it. Okay, cool. Let's say we have W3, W3, W3. Okay, everything's W3. Cool, got it. Simple. All right, everything kind of the same. And all we have are like terms. What happens when we have not just like terms, but like terms and unlike terms, and we're trying to put things together like that. So, one second. So, we need to add together 4x squared minus 5x plus 3 and 2x squared plus 2x plus 1. So, we're going to need to sort these terms out before we can combine like terms correctly. To do this, we're going to make it easy on ourselves. We're going to do the easiest possible thing, because in math, you don't want to do the harder thing necessarily. You want to do the easier thing. So if you can make it easier, you do it easier. You can do it the hard way if you want, but you don't want to. So we want to try to do things the easier way. What's the easiest way to do this? Well, to add the polynomials 4x squared minus 5x plus 3, we're going to try to line up the terms. Stack them on top of each other. This is called stacking, basically. We're going to stack them on top of each other, things that look the same. So we're going to do that. All right, so let's look at our first, let's look at this polynomial. I want to add together 4x squared minus 5x plus 3 and 2x squared plus 2x plus 1. Now remember, like terms have the same letters and powers, which means that the two things that match are the 4x squared and the 2x squared. The 4x squared and the 2x squared. Notice they both have an x squared on them. They match. Okay. I have a minus 5x and a plus 2x. They have the same letter and the same power. They match. I've got a 3 and a 1. They're just two numbers that are by themselves. They match. So then what I'll do is I'll line up the first one. So 4x squared minus 5x plus 3. I'll line it up like this. Then what I'll do is I will line up 2x squared plus 2x plus 1 right underneath it, making sure that things match as I look down. So if I look down, I see I have an x squared and an x squared. Okay, that matches. I've got an x and an x. That matches. I've got two numbers by themselves. Those also match. So when I stack things up, I make sure to keep everything kind of lined up so they match, but also make sure to keep the signs of everything. So the minus 5 stays a minus 5. Okay. Then all I do is just add. 4 plus 2 is 6. 6 what? X squared. Notice that x squared, this x squared plus this x squared gave me a x squared. I have minus 5x plus 2x. Minus 5 plus 2 goes in my calculator, or negative 5 plus 2, depending on how sensitive your calculator is about the difference. So negative 5 plus 2 gives me negative 3x. 3 plus 1 gives me 4. All right? We're going to do the same thing for this problem. We're going to add 2x cubed plus 3x squared plus 12 and 7x cubed plus 4x squared plus 3. So what we're going to do is line things up. 2x cubed and 7x cubed lines up. 3x squared and 4x squared match, so they line up. 12 and 3 match, so we line them up. So we're going to stack them. I've got 2x cubed plus 3x squared plus 12 lines up. So I have a 7x squared right here, or 7x cubed, sorry, 7x to the 3 will line up with 2x to the 3 because they're the same. Look at, just look at them, they're the same. They have the same variable and exponent, so that they match up. All right. Then we have 3x squared and 4x squared. And so these line up, and so we line these up. And then have a 12 that's a number by itself, 12, and a 3 by itself, which means these will also line up. That gives me 2 plus 7 is 9. 9 what? X cubed, x cubed, x cubed. 9x to the 3. All right, I have 3 plus 4 is 7. X to the 2, x to the 2, x to the 2. And I have 12 plus 3 is 15. By itself, by itself, by itself. All right, so that's called stacking method, essentially. What we do, we stack them on top of each other and we match them up. That is the easiest way to add together polynomials. All right, you can also subtract polynomials. To do that, we need to use the distributive property first. So let's go over what the distributive property is. Distributive property. When you distribute, you multiply the number in front of the parentheses to everything in the parentheses. So let's look at the first part of the example. When you have 5 parentheses x plus 2, you've got to deal with the parentheses. You multiply the front number, in this case 5. Let's see it right there. And you're going to multiply it by everything on the inside. What's on the inside? X and 2. So you get 5 times x plus 5 times 2, which is 5x plus 10. Let's look at the second example down here. We have 3 parentheses 7 plus 4. We need to apply the distributive property. 3 times 7 plus 3 times 4 is 21 plus 12 are 33. So the number on the outside of the parentheses can multiply by everything on the inside of the parentheses. And make sure and everything gets in its multiplication. So 3 times 7, 3 times 4. All right. Let's do, I'm gonna look at these other 2 examples. All right. So 5 times 6 plus 2, so 5 times 6 is 30. 5 times 2 is 10. There's a plus in the middle, so we put a plus. 30 plus 10 is 40. 4 times 7 is 28. 4 times 2 is 8. 4 times 3 is 12. 28 plus 8 plus 12 is 48. So that's that. The first step of subtracting polynomials is to distribute the negative to the second parentheses. It will make all the terms on the inside of parentheses change sign. And so what will happen is basically the first parentheses, nothing will change in the first parentheses. However, a minus are essentially a negative, essentially. What does a negative do? Well, a negative turns everything the opposite. So this is a positive 5x squared. A negative will make it the opposite. So instead of being a positive 5x squared, now it's a negative 5x squared or minus 5x squared. This is a negative 3x. The opposite of a negative is a positive. So what happens is negative 3x becomes positive 3x. This is a positive 2. The opposite of a positive is a negative. So it becomes minus 2. So positive 2 becomes minus 2. From there, we basically can use the thing we did before where we stacked things. We can stack this on top of that, stack this on top of that, stack this on top of that, and that gives us this. All right. So in summary, we only combine like terms when we have like terms. So we only add or subtract when we have like terms, and we can line things up. And so that is it, I think. It is.